Okay. Good evening, everyone. It is my great pleasure to welcome you all to the 53rd webinar organized by Metalogic PMS. I am Monica Bachchan, founder and CEO of Metalogic, and I'm truly honored to have you join us for today's session on identifying the probable root cause of structural collapse. Over the years, Metalogic has been committed to bringing together experts and professionals to discuss and address the pressing challenges facing our industry. Today's topic is one of the immense significance, not just for engineers, designers, and architects, but for everyone involved in the life cycle of infrastructure development. I'd like to show you one picture. Just give me a second. Just one second. Shift. Just okay. Is the image visible to you all? You can show me a thumbs up if the image is visible. Okay. So these are some of the collapse projects in the last, I would say, 4 months, starting from April to August. So I'll just name these projects which have been collapsed. Recently, we saw Chhatrapati Shivaji Maharaj statue collapse in Sindhugarh district of Maharashtra. Rajkot Airport canopy roof collapsed after heavy rain. Then Delhi Airport canopy roof collapsed, resulting in fatalities. Jabalpur Airport canopy, part of the terminal building collapsed. 10 bridges in Bihar, multiple collapse over 16 days, including incidents Sivan, Saran, Madhubani, Araria, East, Champaran, and Krishnaganj districts in just a matter of 16 days. Then Atal Setu Mumbai bridge, you would find some cracks appeared on newly inaugurated bridge. Then India largest under construction bridge collapsed in Bihar, and under construction bridge on Manai River collapsed in Telangana. And just today we got a information that railway station at Mizoram collapsed, newly constructed railway station, and there is a runway wall collapsed at Hazira. So the number, these are just the few numbers, let me tell you. The list is very, very long. If I go more and more in detail, structural collapse are devastating events that can lead to the loss of lives, significant economic damage, and a loss of public trust. In recent times, we have witnessed several high profile structural failures around the world, and each incident has raised critical questions about our approach to design, material, construction practices, and maintenance. Let me just close this sharing window. Yeah. This webinar is particularly important because it brings together some of the brightest minds in the field to delve into the roots cause of these failure. Understanding the underlying issues, whether they are related to material quality, design flaws, or inadequate maintenance practices, is crucial for developing solutions that can prevent such tragedies in the future. The knowledge and insight shared here today will not only help us improving safety standards, but also drive innovation in the construction and material sectors. By addressing these challenges head on, we can contribute on building safer, more resilient infrastructure that will stand the test of time. Before we begin, I would like to express my gratitude to our distinguished panelists for taking the time to share their expertise with us. Let us all welcome Mr. Sanjay Singh, Director, Strategy and External Relations, Jindal Steel and Power. He is also a former Secretary of Ministry of Steel. I would like to welcome Mr. Yatendra Pal Suri, co-chairman CII National Corrosion Management Committee, and former MD of Autocompu. Engineer Dr. Abhay Gupta, Director of Skeleton Construction Private Limited. I'd like to welcome Dr. S.S. Gawar, Chief Scientist and FMR Head, Bridge Engineering and Structures Divisions, CSIR Central Road Research Institute, and Dr. A.S. Firoz, Strategy Advisor, Policy and Economic Affairs, and of course, former Chief Economist of Economic Research Unit. I would also like to thank our audience for joining us. Your engagement and input are this is what make this webinar successful, and I encourage you to actively participate in the discussion. Now, as we prepare to explore the complexity of structural integrity, I would like to start with a quick session to our audience. How many of you have been directly involved in a project where structural safety was a significant concern? You can post your answers in the chat box. The question to the audience, you can always post your answers in the chat box. How many of you have been directly involved in a project where structural safety was a significant concern? Feel free to share your experience in the chat as we proceed. Thank you once again for being here. I hope you will find the session insightful, inspiring. Let's get started. Sanjay sir is joining us. So meanwhile, I'll take Mr. Yatinder Pal Suri, sir, to share your words with us. Over to you, sir.
Yeah, can you hear me, Monica?
Yes, sir, very well.
Okay. Good afternoon, everyone. I'll first begin with the latest failure that we have witnessed. In fact, the whole nation is aghast, and it's quite evident by looking at the pictures on television that the structure that we saw failing appears to be a very fragile structure. And what we also understand that it had used substandard materials. There was rust observed prior to its inauguration. No painting and coating was done on the structural inside. And it was a rush construction, in just about 3 months from design to inauguration, which apparently led to poor construction, hasty construction. And experts noted significant problems. Inadequate structural integrity is of course visible. In my opinion, design and material selection was not sufficient to withstand the environmental conditions which prevail in a coastal area. The neglect of maintenance warnings were seen, alerts were ignored, and the adverse weather condition that everyone is talking about accelerated failure of an already compromised structure, in my opinion. The statement of the Chief Minister that 45 km/h wind speed led to its failure appears to be a big joke to all the technical fraternity that we all represent. It was very unfortunate that he also went on to blame Indian Navy, not knowing that as a rule, Navy follows statutory regulations and documents their adherence to systems and procedures of national codes, all in the interest of national security and safety. We cannot doubt it. But somehow, the CM tried to put the blame on them. There was an impact study done in 2019 by NACE, USA, which was sponsored by many of us. It found that Navy scored the highest marks, the highest ratings as compared to the private sector in India. So therefore, doubting Navy's capabilities and blaming everything on the wind speed and corrosion, I think was not good in taste. This would be my initial comments on the failure. Would you like me to speak a little more on the other aspects?
Sir, I think those aspects we will take it in Q&A. I'll quickly move on to the other panelist. Now I like
No,
to welcome.
there was
Yeah,
one
please.
aspect in that case. There's
Yeah.
one aspect that I must talk about. We all, I think Deputy CM talked about corrosion being a reason, but corrosion cannot be a reason in barely 9 months of an installation. Nonetheless, I must tell you that there is a tool which can be used while designing anything on the coastal areas. It is ISO 9223, which talks about corrosivity classes. And this area, I would say, would maybe it would fall in C4, C5, or CX, which are highly corrosive environments. And in such environments, nobody uses carbon steel, and that too for a statue which is supposed to last for hundreds of years. So stainless steel or duplex stainless steel should have been used, but instead carbon steel has been used, and that has not even been coated or painted. Rusting has been seen on all elements and fasteners. You see, in coastal areas, chlorides are in abundance, and so therefore corrosion is accelerated. The higher the class, which is C4, C5, CX, as I said, we need a higher corrosion resistant material. Now, if you look at the statue, the structural elements are all inside the external layer of the dress of the idol. So the humidity levels are far higher than the humidity level outside under the sunshine. And a lot of salt being there in the coastal areas, in the environment, the covered areas become more humid, and because of chlorides and SO2 present, the pH value is lowered and becomes very aggressive from corrosion perspective. So therefore, carbon steel, in my opinion, is not at all suitable for any structure which is supposed to last for hundreds of years. And this was a basic mistake that the designers did. That's all from me at this stage.
Thank you so much, sir. Moving on to engineer Dr. Abhay Gupta. And Sanjay sir is also with us. Sir, request you to please open your camera. Abhay sir, please continue. Over to
Good
you.
afternoon, everybody. Thank you very much, Metalogica, for igniting this very relevant or you can say concerned topic these days. We are certainly shocked by each and every such news which comes with associated with the failure of a structure. I myself being a structural engineer, every time when I hear about any such kind of thing, we start thinking where things have gone wrong. We need to understand the structural configuration. We need to understand the selection of proper material. We need to understand and implement the correct methodology of construction with proper specification. Mr. Suri has very rightly pointed out that depending on the importance of the structure, the proper selection of material is very, very important depending on the location, the coastal region and others also. So very right time to discuss all these things. I would like to just give in a brief to start with that any structural failure which we see, which we are hearing, one is because either the structural design itself had some flaws, or the other second maybe the material compromises have been done. As we all know that there are many projects which are on a fast track. So certainly fast track project need a very, very focused attention and a very skilled set of people to monitor and implement. Third, very, very important aspect which probably is being ignored at many times is the soil conditions, the terrain conditions below the foundation of the structure and surrounding. There have been cases where the structure otherwise was intact, but since the soil below has failed, or there has been a landslide in Kerala, Wayanad, whatever has happened, is not a structural failure, but a devastation because of the landslide. So these are all these reasons we need to consider before we plan and construct any structure, monument, building, bridge, tower, or anything, that whether the serviceability or the performance of that structure would be affected by the surrounding soil conditions. That is very, very important, and hence it is very important to include a geotechnical engineer, a qualified geotechnical engineer in all the projects, and to get a proper soil investigation done. At the same time, structural design is very important, and there are very well documented Indian standard codes of practices and even some international practices which should be followed, properly followed. But whenever we have seen compromise with them, we have seen the adverse effects. We have ignored at some places the proper selection of the material or the load transfer path. If I say in a structure, if it is in a high seismic zone, then proper structural system should be considered. Whatever do's and don'ts have been given in the codes and the guidelines should be followed. And whenever they are ignored, we see the consequences in the form of structural failure. Another very, very important is when there is a fast track project, then material selection becomes very, very important, and the supervision. So together, all these things need attention of the country, and not only the structural engineering fraternity, but the entire construction engineering community, along with the you can say material selections and the specification writers should pay attention that special word of caution and note should be added to safeguard the structures and to perform the way they have been intended during the entire lifespan. So from there, here we will take off further during the question answer. Thank you very much.
Thank you so much, sir. I'll next move on to Mr. S.S. Gahawar. Sir, over to you. Please share your input, sir.
Thank you, Monica ji, and good afternoon to all my fellow panelists, as well as the attendees who are participating in this event. Talking in terms of failure of the structure, it's a very painful thing, because nowadays ours is you can say Indian economy. We are ranking 5th in the world, and of course the whole world is looking towards us, and rightly so, that a lot of development, especially government, has given a lot of emphasis on the infrastructure development. So it is always pleasure to talk about the development, but it is at the same time equally painful to talk about the failures. But failures, they are part and partial, and of course they do not figure out in the wish list of any, you can say, countryman, responsible countryman, but at the same time they give important lessons. And here we are discussing today, our main objective is to just find out what lessons, what shortcomings have been observed to the reported failures, observed failures, and what lessons we can take so that they can be minimized. When I say they, means such type of failures can be minimized. I come from the, you can say, bridges and flyover discipline, but my, you can say, earlier panelist, they talked about and rightly talked about the burning, you can say, failure of this Shivaji Maharaj, Shivaji's statue, 35 feet height, and it came to as a surprise, but of course very painful. Suriji rightly discussed about this improper selection of the materials, and of course the structure environment interaction. And Abhay Gupta Saab rightly mentioned about the importance of this geotechnical investigations. Now, as per my perception, any infrastructure project which also covers this, you can say, monumental project, and I know that Dr. Abhay Gupta specializes in this discipline. So, and I come from the bridge and flyover. whenever we foresee or conceptualize the project, it starts with the conceptualization of the project, starting with the preparation of the DPR. Then it enters into, you can say, the design stage, and then it comes to the implementation stage, and afterwards it goes to the operation and maintenance aspect. And of course, maintenance is very important. And of course, at the fag end, it is the rehabilitation stage. So failures which have been reported, which have been observed at various stages, there is a component. So if there is any shortcomings or some overlook has taken place at every stage, then there is a possibility that the structure may not serve its intended purpose throughout its design life, and its service life, effective service life, gets shortened as compared to its design life. Now coming to the DPR stage, you can say we talk about, you can say, fast track construction, but we should also keep in our mind that there is a proper incubation period. So if this proper incubation period plus the lack of expertise, if these two things they are ignored, probably the cooked project in terms of DPR, that is not perfect, and it is bound to give some, you can say, problems in the next stages. Coming to the design stage, if some design deficiency is there on account of, you can say, improper detailing or overlooking, then it becomes a very difficult phase, because this design, once it gets approved, then it is very difficult to rectify it, because the structure for implementation goes on the basis of this design. So this design deficiency is also very serious. Next comes to the, you can say, implementation stage. Again, here you can say the incubation period, or you can say the construction period, optimum construction period, that is very essential. If you don't allow proper construction period in terms of its, you can say, optimum duration, then what will happen? You can say you are likely to get problems in future. We have seen recently beautifully constructed structures, of course, where the competency is not at all in any doubt, but even those structures, without naming, they have started giving some problems, of course, minor problems. So this is one, you can say, symptoms is there. Then comes the skill of the, you can say, execution. Now, nowadays, traditionally, our country was, you can say, dominated by the manpower construction. But here, over a period of time, it is coming towards having a proper balance with the mechanized construction and manpower construction. But in this, if you see the proper distribution of this, is still the stakeholders which are involved in the construction practices, they are probably not equipped with the latest construction equipments, and of course their operation and maintenance, and of course there are so many factors which we will be discussing in the time to come during the question answer session. And then comes, you can say, the skill of the people. That is also a gray area. Skill means upcoming engineers, means that practical skill, that is also there. And of course, one aspect which we are missing, and which is very relevant, that is the resilience. Nowadays, this climate resilience, that is also posing a serious challenge. And of course, force measures, if some, you can say, beyond control phenomena like earthquake, or you can say the high wind phenomena that takes place. Of course, the subject failure of the monumental structure, there it has been talked about, you can say, the high winds also. So that again strikes back to the proper design of the structures. Coming to the maintenance aspect, that is of course a very gray area and challenging area. Maintenance, if it is not given due consideration, we have seen recent failure, a series of failure in Bihar. I'm talking about the bridges. Of course, that high flood, you can say, that has been one of the main reasons, but improper maintenance, that was also there. So coupling all those things, I think they are all having, you can say, important share, which may lead, if ignored, to the failure of the structure. So I just end up my first portion here, and I will continue in the question. Thank you.
Right, sir. Thank you so much. I'll move on to Sanjay Singh, sir. Sir, are you all able to see him? I'm just making him into a spotlight so that everyone can see him. Welcoming you, sir. And before we start the Q&A, I would like to have some words from you, sir, to open the session, sir. So please unmute.
Thank you, Monica ji, and namaskar, everybody, all those who are visible and all those who are not visible. So, in fact, I have heard from the experts in this area about various aspects and which need to be taken care of and which have been found to be deficient. I'm not going to speak about that. I just want to say why and how we can improve this. One thing I would upfront like to mention that right now, the pace at which we are growing, and it's 8.2% was the growth of Indian economy in the last financial year. And a large proportion of the budget has been kept for infrastructure and construction. And the government has put a lot of focus on this area. But where is the deficiency? We are constructing hundreds and hundreds of kilometers of national highways every day. And so where is the deficiency? I'll say there are three areas. The first one would be, in fact, apart from like you start from the I'm in the community of engineers right now. Starting from the highest level of engineers, which are produced in the best of institutions, that how many of them are joining civil engineering now? Civil engineering is not a very, very sought after course. And everybody wants to go in for which kind of areas? It's software development and electronics and all these areas. Now you come to who is essentially doing the work in the field. Is our supervisors, is our technicians who are the pass out from, I'll say, ITIs and so on. So there again, I'll say construction and infrastructure are not very. If we consider that, of course, everything is fine in ITI, the curriculum is up to the mark, and everything is okay, then not many are joining these areas as well. Reason being, because one has to be in the site, one has to be the hard kind of terrain and hard kind of environment. So they do not want to be, and one has to work at height and so on. So according to me, the deficiencies are number one, since now we are on the path of becoming third largest economy in the world and becoming Viksit Bharat by 2047. So Viksit we can become if certain things we imbibe and we move on to the higher orbit. Higher orbit in terms of our technological competence, absorption of the right kind of, I say, technologies and skilling. And to me, the one most important thing which is required to be focused and which has been adequately focused in this year's budget, and that's skilling. And the 60,000 crore rupees has been kept for skilling this year. So, but it's not the money. It's about what kind of skilling is to be done, what skill is to be imparted, and who is going to skill. Do you think that construction sector has the wherewithal to skill? Because some time back, I was heading a committee of CIDC on how to increase the consumption of steel in the construction sector. So there, the most important thing was skilling on all front. Skilling in designing, skilling in architecture, skilling in construction. And above all, skilling in terms of the modern and high-end technologies. Now we are constructing, in fact, as has been mentioned, if those kind of technologies are imbibed into our construction, kind of ecosystem, then these things would not happen. I'm talking about the BIM. I think building information modeling. I mean, that covers everything. And whatever precision is happening in terms of planning, designing, and into construction, even for that matter, maintenance, I mean, that can be taken care of. Then there's certain things which I for one is, of course, there's some of the agencies, some of the companies which are using BIMs in India. But like, for instance, I'll say the kind of materials which are available right now for construction, which are advanced kind of materials. I mean, that one only reads in books. So there is so much of, I'll say, digitalization, advanced technology, computer-aided precision, which can be imparted to construction. If that is put together and in the construction area, I mean, definitely it can make a huge difference. But the problem lies, who is going to how the skilling is to be done on all these fronts, and who is going to skill it. So unless we address this, and government also is putting in a lot of money, and what kind of skilling model. That is another, because we have tried several skilling model. We initially, the government institutions did skilling. Later on, it was in the PPP mode. Then it was given to NGOs and those kind of agencies to do skilling. But so how the skilling is to be done? So we have to focus on these aspects. And I'll say that regarding my company, which I am working in right now, you would have heard in the parliament, our chairman Naveen Jindalji, he mentioned about how important is skilling. I mean, during the budget discussion, and from the company side, he has announced that he's going to set up 2 state-of-art, highly technical kind of skilling institutes in the country. And of course, upgrading the ITIs also are there in focus. So these are the kind of things which not only one person, I mean, all over this kind of an ecosystem has to be generated, has to be created, where everybody is contributing towards skilling. That's one thing which can put us in a higher orbit. Thank you.
Thank you so much, sir. And last but not least, I'll have Dr. A.S. Firoz. Sir, over to you. Please share your views, sir.
Thank you very much, Monica. Can you hear me? Am I audible?
Yes, sir. You are very much audible.
Yeah. Of course, in recent times, we have been hearing about various kinds of structural failures, whether it's related to a road bridge or railway bridge or a station or a flyover in a city or many other, or a tunnel or even canopies in an airport of various types. I mean, failures have not been just one type of failure, one place. There's multiple areas where we have observed failures. There are some commonalities, yes. One, I can see there are 3 canopies of airports had fallen in front. Somebody must have taken the same CAD design and used it, or maybe same contractor used it, and all 3 of them have failed. Now, these are some of the things some of the visuals which don't look so nice and doesn't talk very good about the country's progress. But let me come back to some statistics. From between 1977 to 2017, that is 40 years, we had 2,130 recorded collapse of bridges and major culverts. Okay, this is the record. And the government study says that 83% of those were only due to natural disasters, natural calamities. So only 17% of that could be attributed to structural failures in design or something, whatever, maintenance, etc. Now, in this last 2 years or so, what we have seen, irrespective, I don't have a count of these numbers, but definitely frequency of this happening is very high and are of matter of great concern, because before these were in fact, set up, they have fallen. Supposing if bridge, 10 kilometer long bridge in Bihar had fallen when it is under construction. In Mizoram, a rail bridge had collapsed before when under construction. And then so many flyovers we have seen in the cities in Gujarat or somewhere else. So the problem, I think that from the technical point of view, obviously there are better brains over here to talk about starting from negligence or not inadequate work going into the planning part of it, while it is, whereas it is soil testing, where it is proper area planning, so many things. I have seen a case of a flyover stopped halfway through because it was not this, and they did not know how to complete the project. It was stopped halfway through. And second, these kind of things which are happening due to even natural calamities, which are smallest of the minutest of the natural calamities. I mean, so Chhatrapati Shivaji statue had fallen when there was a wind at 45 kilometers an hour. And if you look at the picture of it, that entire statue is rested on two angles. If you look at the picture properly, mild steel angles, it did not even look like a strong angles, supporting angles. So it had fallen and it was facing, the wider part of the statue is facing the wind. So obviously it could not take that kind of a pressure. Now, my reading is this, that as we go into this particular problem of preventing this kind of collapses, we'll have to devise a financial model, contracts properly, and done properly, designs going along with the synchronized with the materials and other aspects, other engineering aspects of it. There has to be a synchronization of all that. And how to prevent it, I mean, how to punish, I mean, that's another part of it, a very important part of it. Who's responsible for what? Supposing the structure of the Shivaji's statue has collapsed, and the one who has been arrested, he makes a claim that my job was to make the foundation only. I had nothing to do with the structure. He is very right. There's nothing that the foundation has remained intact. So who is responsible? Who will be held responsible for anything, or if they can legally be held responsible after the project is commissioned? There are different court decisions, Supreme Court orders, High Court orders on various aspects of it. Even the bank guarantees cannot be held back. They have to be released once you say that the project is complete and completion certificate is obtained. All this has happened except for those which are under construction. Most of them have got the completion certificates. So they have been issued by the employing agency. So what we are trying to say that will have to look at multiple aspects of it, and also we'll come back to the losses that can come on account of it. But from contracting to engineering to design, all this will have to be taken together to examine a project before it is launched. Thank you.
Thank you so much, sir. And we will start our question and answers. And I also suggest the audience to raise your questions in the Q&A box. You will find, because this Q&A box will be visible to all our panelists as well. So as we start the question, my first question goes to Mr. Yatendra Suri. So corrosion is often an overlooked factor in structural integrity. Can you discuss how corrosion contributes to structural collapse and what preventive measures can be implemented to mitigate this risk?
Okay. Thank you, Monica. Monica, I would like to say a few words on the structural integrity, which is related to corrosion. We all know it's the ability of a structure which is consisting of many components. Now, when you look at this Chhatrapati Shivaji There were all kinds of materials involved. So there are many components to hold together under a load without breaking and to perform its designated function for as long as its intended lifespan. I'm sure the lifespan for this structure was hundreds of years. Naturally, this failure is initiated when a structure is stressed beyond the design strength limit. Now, structural loads are important considerations in design stage. The building codes are there to build to safety and resist all actions likely to face during service life. Now, there is something called a dead load, which Abhay probably would speak more on that. Live loads, if it's a bridge, then, vehicles passing through the bridge. Then environmental load, where, your wind speed and your monsoons and all kinds of things, related to environment are to be taken into consideration. And the other loads, which Abhay talked about, foundation settlement and corrosion, etc., are to be looked into. And all these need to be inbuilt in design stage. So corrosion also is an aspect which is falling under the designation of other loads, which needs to be taken care of. Now, depending on the life expectancy, either we select a material which will last for hundreds of years, or we select a coating which will ensure that the structure lasts for its designated intended 15-20 years of lifetime. Now, if you talk about coatings or paintings, the important thing is about availability of certified coaters or painters, the applicators that we call. Because we have lack of regulations. Sanjay ji talked about skilling. So skilling is all right, but we have lack of regulations related to required qualifications of people involved. Now, if somebody has to do coating and if an applicator, certified applicator is not available, be rest assured that the coating will not have its effect and corrosion will set in and this structure will not last as long as it is intended to be. So corrosion definitely is an electrochemical process. Closer to coastal areas, it is more severe, and also because temperatures are very high, it's all the more reason. Unfortunately, the chloride levels in our sea coastal areas is as high as 15,000 ppm, which is definitely much higher as compared to Japan or Europe. So therefore, many of the solutions which are available in Japan or in Europe, we cannot replicate them in India, with our eyes closed, overlooking the fact that we have very high temperatures and we have very high chloride levels. So corrosion is an aspect which has to be taken very, very seriously. To be very frank, we have from CII started a national mission on war against corrosion with support from Ministry of Steel as well as Niti Aayog. And that was basically kick-started by our Prime Minister, Shri Narendra Modi, when he went to USA in 2014 and signed an MOU with President Obama to work together on corrosion control activities in India. You see, we have 7,000 kilometers of coastal line. Therefore, anything we create along the coastal area is subject to quick corrosion. And therefore, it is the responsibility of all the designers, as Sanjay ji said, at DPR stage or at design stage, we have to take corrosivity of the environment very, very seriously and take corrective measures while designing the structure and also while advising the maintenance people on how to ensure that they get the intended life. I hope I answered your question.
Yes, sir. Anyone likes to add to Mr. Suri, or shall I take the next question? So, and I request all the panelists to keep a check on the Q&A window. I hope it is visible to you. There are many questions coming up. Like just now, Naresh ji has posted a question. Naresh Kumar, he's asking what action have taken from authority for contractor and designer for collapsed bridge. So there are plenty of projects which have collapsed. So what kind of actions do authority take? So if anybody like to answer, as in just the procedure, what kind of procedures are there when we talk about the actions? Abhishek, you want to say something on this, or Mr. Gawar? What kind of actions usually are taken care by?
As I said, we are a developing country. We have lack of strong legal framework to deal with consequences of failure. I think this is at the evolutionary stage, and going forward, I'm sure we would have legal frameworks which are comparable to the best in the world.
Can I supplement?
Yes.
For infrastructure project, you see there is a legal document, contract agreement, as if it is a EPC project, and if it is a PPP BOT project, it's a concession agreement. So there, any, you can say, fault on the part of the contractor, or you can say the independent engineer, supervision engineer, that is there. So those actions, they have also been defined. As far as the authorities are concerned, authorities have their own protocol, of course, very much in line with the, you can say, the framework of the contract agreement or concession agreement, and you can say the actions, they are initiated accordingly.
Right, sir. Yeah, Abhay, sir.
I see in the questions there is one from Mr. Hemant. Our L1 system is partially responsible for the mess. In country, there are two types of the projects. One are the private projects, one are the government funded projects, which are under EPC mode nowadays. Now, as somebody has pointed out rightly, that L1 system is responsible. Yeah, to some extent, but many of the contracts are even awarded with the pre-qualification. So when there is a stringent pre-qualification system, the quality aspects are also taken care of. But there is a better system, which probably I heard about that in one of the recent conferences also, about the QCBS system of the contracts. It is a quality and cost based system. So when the cost only is not the criteria, when the quality is also along with mixed up together integrated, then certainly you get a better agency to work. So that is one aspect of the entire contract system where we can control the quality and the performance. In private sector, certainly QCBS is always followed. Any of the private promoter, they will always consider the quality of the agency first, and then they will certainly discuss over the costing. But more than that, actually on paper we do many things very good, rather everything very good. All the competent structural engineers, qualified and competent structural engineers, they know their job well, and many of them, I'll say not 100%, but people with a lot of experience in that, they really perform a very good design, and on paper we really produce very good. But as someone has pointed out in the QA box, Mr. Hemant, again, we seriously lack in imparting training to the actual workforce who is constructing and supervising. So this is one of the main reason of one of the prime factors of inferior quality being delivered. Actually, there is no proper system in our country of the training to the workforce which is there. So that upskilling, as Sanjay Singh sir has also mentioned, that upskilling of the manpower which is involved in the construction. I heard, I visited Singapore a couple of months back, and I got to know that any contracting agency which is using a trained force, certified workforce, they have to pay much less amount of the insurance cost on their labor insurance and other things. So that's an incentive given to them. Maybe if somewhere that can be considered in our policies, all our construction agencies would be inclined to get the training done. There are so many of training organizations, I know, but certainly they are not being utilized the way they should be. So imparting training to the workforce will certainly help in converting whatever we do good on the paper to the field. So that is one part of the quality construction. Maybe design, as one of the queries I heard, that whether the design flaws, how the design flaws can be eliminated or controlled. So the best way is to always involve a third-party independent proof consultant. Actually, there is a misnomer. I'm not sure how well it will be taken up, but in many of the government projects, they mention the design should be approved by IIT. Now,
Right, sir.
Just by becoming a faculty at IIT does not entitle any professor or faculty to really be an experienced design reviewer. There are several private practitioners, independent practitioners who are far better, who are experienced. So rather than just saying blindly that IIT should vet, those agencies should add a qualification note, an IIT professor with so much of experience in the relevant field. That will help a lot, means in proper review of the designs. Otherwise, private developers, they always appoint a third party independent review consultant or value engineering consultant, and we have seen them really giving very good inputs in the entire process of the designing. So that helps to a larger extent avoiding the mistakes. I'm sure with the bridges project also Dr. Gairwar would be supporting me in that all bridge projects are certainly reviewed at 2 or 3 levels. So bridge design challenges are overcome because of that, or maybe for that matter any structure we have been doing, as has been mentioned.
Exactly. So this is what my question is from Mr. Gawar. Based on your research and experience in bridge engineering, what are the most common causes of bridge collapse, sir, and how can they be prevented through better design and maintenance practices?
Yeah, first of all, means just I would like to supplement Dr. Abhay Gupta's you can say statement that the proof checker, of course, that is one solution when the design deficiencies they are observed. One independent, you can say, proof checker, and rightly mentioned by Dr. Gupta that proof checker should be, you can say, an experienced professional, means fully conversant with the design of bridges. Now, one of the you can say shortcomings in our education system is that bridge engineering, I'm just talking especially focusing the bridge engineering. Bridge engineering, that is not a you can say curriculum subject. So that is one thing where the professionals they can play. You can say having a good knowledge base, a good proof checker. So that is what I wanted to supplement. Coming back to your, you can say, we cannot generalize. As in my first, you can say, session, I just mentioned that there are a variety of reasons where they equally, or you can say, contribute if any shortcomings is ignored. Starting, as you mentioned about the design aspect, yes, design aspect means in this statue part also, which we have been just discussing. Probably when we are discussing about this wind interaction, and we have seen, you can say, some of the photographs where the failure of the statue is there, and one of senior panelists mentioned that remaining part means very, you can say, very thin. So that gives, you can say, the idea that you can say improperly designed structures. That is one of the main reasons for the failure. That detailing aspect, and detailing particularly whenever means these structures they are located in a very, you can say, aggressive environment, like the one in, you can say, this corrosive environment, and of course high wind, you can say, since it's a navy, you can say, portion, and then statue, so that high wind interaction that is there. So some expert dealing with, you can say, the design aspect, taking into consideration the proper wind effects, that input should have been there. I, through the newspaper, came to know that PWD, they just handed over, you can say, to Navy, and Navy on their own, they went for the construction of that. So there is a possibility that not at micro level, you can say, consideration of design aspects might have been there. But barring this structure, coming back to the bridges, there also the detailing aspect that is very important. You can see if any of, you can say, the factors they have been ignored, then you can say the third party proof checker of course, the knowledge-based professional that can fill up the gap. So that is one aspect. If we follow this trend, probably we can address the aspect. Another aspect is that when we enter the execution stage, particularly I'm talking about the long span, you can say very typical design structures where the bridge launchers, they are also coming into picture. So many times what happens that the, you can say, incidental load of a launcher, that has also not been taken into consideration while designing the structural component, particularly the pier cap, etc. So there, once the construction is completed, then afterwards, those you can say shortcomings, or you can say the incidental loads, if they have created some adverse effect and they have been observed also, those things they are remaining. So this is also one of the very important aspect, that incidental load means any shortcomings. If the third party intervention is there in the proof checking of design, so that is taken care of. Launching, when I say the launching, even the launcher's design, it differs from one bridge span to another bridge span. In my career, I have come across one failure, without naming the, you can say, the structure, where the launcher's design and fabrication, that should have been very, you can say, carefully done. That was taken care by the contractor, saying that if this launcher of this configuration has served L1 span, then it is my L2 span. I can reduce it, and whatever is the reduction, I am prepared, and that is my launcher. So somehow that failed. So this is also one of the, you can say, approaches which maybe you can say adopted by other people. So some such things at a micro level, they are also happening. I mentioned about the skill of the people also. Even the people who are deployed at the ground level, they are also not having proper skills. So that there is an ample scope for training of those manpowers. And of course, the internal training department that should be there. And of course, means there should have been an internal quality control department also. I'm talking about the contractor or concessionaire side, without making any compromise. Because that is the first level of check. And of course, the stakeholder, the owning agencies, they should also have a proper quality control department, either in-house or through, you can say, the external intervention, like independent engineer or engineer. And that engineer, when I say nowadays in infrastructure project, the trend is such that it is not a single engineer. It is a team of engineers dealing with different, you can say, aspects. One person is dealing with the highway portion, one other is a structure portion, one is dealing with the environment. So those design or team, that should be capable enough. What is happening, without just going into micro level, what is happening at the time of procurement or taking the award of this, you can say, supervision team, they produce one team. And when it comes to the deployment of the team at ground level, this is, you can say, some different team. And needless to mention that there is a difference between the first team and the second team. So that is also one of the major factors why the quality is, you can say, suffering. Now, how to take control of that? As I mentioned, that a strict protocol, even if it is a BOT project, where the independent engineer has a full say and the authority has less to do. Again, taking the cognizance of, you can say, series of failures, it should have been the, you can say, approach to be adopted by the authority. This is just proposal I'm just mentioning. They should take care of, there should not be any compromise in the skill of the persons deployed there. So that is one thing. One example I'm just mentioning, that whenever some quality assurance or quality control aspect is there, and contractor is given a call that is called as a request for inspection, they play in terms, wherever they just find out where the, you can say, the team of engineers, independent engineer that is there, and they mention in a very short span of time at another location that request for inspection that is required. So sometimes it becomes very difficult changing from one position to another position by virtue of this, you can say, length of the project. So sometimes this also attributes if something goes wrong in terms of the quality. So if we take, you can say, a micro level consideration and address these aspects at micro level, probably we can come up with improved quality. And for major projects, as I mentioned, that intervention of, you can say, the technology, we can address, we can improve the quality. For example, for critical bridge components or a typical design, nowadays we are going for the instrumentation of bridges. Instrumentation of bridges, non-destructive testing techniques, even those techniques, they are not traditionally employed, but for importance, seeing the importance of the structure, they can be employed even at the green stage. Green stage means when the concrete is going on, so that the different structural elements which are very important, if their concreting is going on, then the complete control, once the traditional tests have been conducted, we can have the interaction of those non-destructive testing depending upon the requirement. So that can further add use of drones. If some, you can say, large, you can say, one section is going on at one place, another section where the construction activities are going at different places, monitoring of those, intervention of drone, you can say, that can also help. Instrumentation, suppose a structure is having very typical design, so there at the initial stage where the design is based on certain assumption, then the initial performance, at least there is no harm in investing a little bit of money and keeping the instrumentation, so that the output of those instruments immediately gives some sort of warning. So see,
Right, sir. Right, sir. In fact, we have done several programs recently in the last 3-4 months, I would say, where we have extensively talked about the applications of drones and AI and how we can, capture the real-time data and we can utilize that data. But थोड़ी सी अजीब बात ये है, as in not coming to this, but coming to your previous point, सब कमिंग ऑन टू द संजय सिंह सर, पुराने जमाने में इतने इंजीनियर्स भी नहीं थे, इतने आर्किटेक्ट्स भी नहीं थे और इतने बड़े प्रोजेक्ट्स भी नहीं होते थे, लेकिन आज भी उनके स्ट्रक्चर्स एकदम स्ट्रांगली होल्ड करते हैं. एंड दैट टू बी नाउ व्हेन वी हैव सो मेनी इंजीनियरिंग कॉलेजेस, so many institutes which have opened in the last 20 years, I would say 25 years, having such a strength, and still there are so many projects failures we are seeing. So आपको क्या लगता है संजय सर, प्रॉब्लम कहाँ आ रही है? हम जब स्किलिंग की बात करते हैं, मतलब पहले के टाइम के जितने भी स्ट्रक्चर्स हैं वो अभी तक खड़े हुए हैं, जब इतना इंजीनियर्स भी नहीं थे हमारे पास, और आफ्टर हैविंग सो मेनी कॉलेजेस, इंस्टीट्यूट, सच अ स्ट्रेंथ, एज इन इंडिया इज द यंगेस्ट कंट्री बोला जाता है, वी हैव यंगेस्ट स्ट्रेंथ, उसके बावजूद जितने फ्रेशली लॉन्च प्रोजेक्ट्स हैं वही कोलैप्स करे जा रहे हैं. कमी कहाँ पे दिख रही है सर? बिकॉज अगर हम हावड़ा की भी बात करें, वहां पे भी ब्रिज इज स्टिल स्टैंडिंग. अगर हम तमिलनाडु की बात करें, देयर इज अ रेलवे लाइन विच इज बिल्ट 100 years ago, वहां पे भी सॉल्टी वाटर है, मॉइस्चर है, सी लाइन से सीधा सीधा रेलवे ट्रैक जा रहा है, नो इफेक्ट एट ऑल. सो एवरीथिंग इज 100 years पहले जो चीजें बनी थी वो अभी भी खड़ी हुई हैं, बट अभी कुछ भी होल्ड नहीं कर पा रहे. संजय सर, सर प्लीज अनम्यूट.
या मोनिका जी, इनफैक्ट यू इनडायरेक्टली मेंशन्ड कि जो पुराने जमाने के जितने स्ट्रक्चर्स होते थे वो क्यों अभी भी खड़े हुए हैं, और उसमें किस तरह के, आई से वेदर दे आर द मेटालिक स्ट्रक्चर्स और दे आर द दैट उसमें corrosion नहीं होता है, रस्ट नहीं होता है, वो खड़े हुए हैं ऐसे के ऐसे ही. इट्स ऑल बिकॉज ऑफ, आई से जो वो कार्य कर रहे थे उसमें दे वर एक्सीलेंट. जो वहां पर कंस्ट्रक्शन वर्कर्स थे, they were of that level that who were really proficient, extraordinary in their work. They might not have been they were not so much of proliferation of the number of work which was happening, but उन लोगों को अपना जितना काम था वो बहुत थॉरो थे उस चीज के बारे में. Now what is एक सबसे बड़ी चीज है हमारे माइंडसेट हमारा क्या हो गया, सब चलता है. दूसरी चीज होगी जुगाड़ कर लो, तो जो इस तरह का हमारा जो माइंडसेट है कि वेयर वी आर कॉम्प्रोमाइजिंग ऑन एक्सीलेंस, आई एम टॉकिंग अबाउट एट द इंडिविजुअल लेवल, और तो उसके कारण से हमारे जो स्ट्रक्चर्स हो और बाकी एक्टिविटीज में उनमें एक्सीलेंस एंड द काइंड ऑफ level upgrade, the level we want to achieve, that we are not being able to achieve. But I think right now, construction area has undergone a total transformation. जिस तरह की टेक्नोलॉजिकल, जिसमें डॉक्टर गवार साहब ने भी जो बहुत सारी चीजों के बारे में हमें भी बताया है कि that what all is happening, this all about tech, but we have to really adopt, assimilate that kind of technology. Destructive test, non-destructive testing you mentioned about. I'll say that now there are also concepts of predictive maintenance. Predictive maintenance के लिए आपको डेटा चाहिए, वो डेटा आपको सेंसर से मिलता है और बाकी ड्रोन वगैरह से मिलता है, तो उससे हमें पता चल सकता है कि किस प्रकार से हम जो है प्रेडिक्टिव मेंटेनेंस कर सकते, पता चल जाएगा कि उसकी लाइफ कितनी बची है, कहां पर क्या चीज को हमें दूर करने की आवश्यकता है. बट अगेन what I am saying is it boils down to skill set. इसमें कोई
and I am sorry to interrupt, मुझे लगता है पहले टेक्नोलॉजी नहीं थी लेकिन टेक्निक जरूर थी. अभी टेक्निक नहीं है, टेक्नोलॉजी बहुत है.
माइंडसेट भी है. एक माइंडसेट बहुत इंपॉर्टेंट चीज है कि जिसमें हम बात करेंगे कि अभी ये है कि चलो आप काम किया, छुट्टी हुई, तो माइंडसेट, जो इस तरह का माइंडसेट, वही हम बात कर रहे हैं, हमारे प्रधानमंत्री जी उसकी बात करते हैं. अगर हमें विकसित भारत की जब डायरेक्शन में हमें जाना है तो हमें माइंडसेट भी अपने परिवर्तन करने की आवश्यकता है कि हमें उस तरह के माइंडसेट की आवश्यकता है कि हम स्ट्राइव फॉर एक्सीलेंस. जो कार्य हम कर रहे हैं उसमें प्राइड लें, उस काम को बहुत अच्छी प्रकार से करें, और टेक्नोलॉजी हमारी बहुत सारी चीजों को आसान करती जा रही है, पर टेक्नोलॉजी हमें रिप्लेस नहीं करती जा रही है. उससे हम बेहतरीन चीजें बना सकते हैं और मेंटेनेंस कर सकते हैं, डेटा हमारे पास में आ सकता है और प्रिसिशन से हम काम को किया जा सकता है. बट अगेन टेक्नोलॉजी होगी, मगर टेक्नोलॉजी को यूज करने वाले लोग चाहिए, उसे पढ़ने वाले लोग चाहिए कि जो उसे डिप्लॉय कर सके. उसके लिए स्किल सेट की जरूरत है. वही मैं कह रहा हूं कि इसमें एक कोई एस्पेक्ट नहीं है कि जिसमें हमें एक पूरे इकोसिस्टम है. उस इकोसिस्टम को हमें एक डायरेक्शन में ऊपर बढ़ाकर उसे इंप्रूव करना है. There's some holistic kind of a thing which is required, and I'll say unfortunately in the construction sector, जो और बाकी सेक्टर्स में जो टेक्नोलॉजिकल अपग्रेड, स्किलिंग अपग्रेड बहुत हो रहे हैं और स्किलिंग हो रही है, और जो हम कहेंगे एट द जो एक बेंचमार्क है उस तक वो पहुंचे हुए हैं. बट इसमें हमारा बेंचमार्क अनफॉर्चुनेटली कंस्ट्रक्शन सेक्टर में क्या है, जो हमारे रूरल डेवलपमेंट के या रूरल एम्प्लॉयमेंट के डेवलपमेंटल वर्क्स होते हैं, वो हम कंस्ट्रक्शन वर्कर कहते हैं. तो हमें वहां से ऊपर लेकर जाने की जरूरत है. और जो so that is what, so skilling in this area is required and everybody has to really contribute towards skilling.
Can I add one comment, Monica ji, with your permission? And I would like
sir, please
Dr. Abhay Gupta to respond. I am, you see, all the old installations that you talked about, 100-year-old, 150 years old, they were all built by Britishers as per British design. And to the best of my knowledge, the British factor of safety is the highest in the world. If you compare them with Germans are far more, on the lower side. So is the British design responsible for longer life of their installations as compared to the new installations that we are designing now? Dr. Abhay, can you comment on this?
Sir, as far as Indian codes of practices are concerned, we are following almost the same as the British codes. Our current IS 456 is more or less a copy of BS 8001. Our factor of safeties are almost similar. Earlier, we were into the working stress method of design where there were rather higher factor of safeties. But as you gain more knowledge about the things, as you get more surety about the data, so like we have switched over to the limited state and plastic design. So we are utilizing the material to a higher level of the strength. So that is same thing is being done worldwide. Standard wise, factor of safety wise, there is no issue. There is no difference even if you compare with the British and the Indian codes of practices. But what happens, what I was trying to highlight again, that On paper, we do very good. I will write on a design, this structure is designed for M30 grade of concrete. Now, as a structural designer, I finish my job there. Actually, but what is the concrete which is being made, supplied, poured, and finally achieved? That is very important. So every aspect of that one material, concrete, same thing happens with the steel, same thing will happen with other materials also. I would like to quote here about the example of one of the iconic monumental structure that we have done is a 351 feet high Lord Shiva statue at Nathadwara. It is world's tallest Shiva statue and world's largest any kind of statue. And it has been designed for 250 years of life. You will be surprised to note that from where I got this figure 250 years. Our client wanted 250 years of the life. Then I thought that how do I achieve this thing? So the achievement of any design service life doesn't come from current codes or practices. They talk about 50, 60 years of the life. So we had to extrapolate those numbers about the permissible stresses, about the durability performance, about the loads like wind and seismic load for 250 years of life. So we did all those exercises. So a very meticulous working on each and every component was taken up regarding the material, the consistency of the material which will be used. So all those things during the construction means converting from paper to the actual design and then doing actual construction and then curing. In case of concrete, the curing is very, very important. So we need to involve one good concrete mix designer if it is a concrete structure. Generally in all mega projects, they are there. Good experts, subject matter experts are there. But whatever failures, some of the failures which we have seen. Now this 35 feet Shivaji statue. This is for any standard, it's not a very big statue. 35 feet is just 10 meter, 3-floor building. And I'm sure that not much of engineering was done. Looking at the pictures, very thin, fragile members of the steel angles which are corroded. I don't know whether they were really of the proper make procured. And then execution, what about the nut bolt and connections, and then anchoring with the ground. Correct. So I don't think that much of engineering was really done on that statue project. We have done statues right from 20-25-30 foot se leke 350 foot tak. And with each and every such very important structure, we had to do a lot of good engineering into that. So
Abhay sir, I want to ask one question. Whenever you built any structure, any statue, आप कितना lifespan एक average consider करते हैं for that statue?
Generally, for any monumental structure of this kind, 100 years of life is prescribed. But in many of our statues, the material which is used is bronze skin. In Shiva statue, it is concrete skin, and inside is the steel structure. But in other structures, like in Ayodhya, we have done Jatayu and Veena at Lata Mangeshkar Chowk. Now, these are bronze and inside is stainless steel because they have been thought of like 1,000 years. Bronze lasts for long. Sardar Patel statue, Statue of Unity, is having a bronze cladding on the external side completely. So those things, though they claim 100 years of life. So for monumental structure, it is 100 years. Only this one particular, but at Ayodhya, temple has been designed for 1,000 years of life. You all must have heard those experts discussing. Dr. T.G. Sitaram, who is currently chairman AICT, was one of the members of the committee. So he explains how the all foundation work has been done for that. In concrete, one of the detrimental factor is presence of the reinforcement inside, and due to the porosity present in the concrete and the external environmental factors, corrosion starts after some time. So either if I follow Professor Mr. Suri, then stainless steel rebars are best. Nowadays, some coatings are also available. FRP rebars are also there. But if you really look at the concrete, whatever rendering, the finishing, the plaster we do on the concrete is detrimental to the life of the structure. Actually,
so I'll quickly move to, yes, sir. Right, sir. So I'll move on to Dr. A.S. Firoz. I want to ask you, sir, what economic implications do structural failures have on a national scale, and how can investing in better infrastructure quality mitigate these risks, sir? क्योंकि इसका एक इकोनॉमिक इम्प्लीकेशन भी बहुत बड़ा है when we see so many structures falling. In fact, the news report which Mr. Yatendra Suri was talking about the fall of Shivaji statue, उसके erection में ही 2.5 करोड़ का investment था only on the erection. So I want to understand from you इसका economic implication क्या है when so many structures are falling, how does it impact, sir?
See, as far as the economic immediate cost is concerned, this is the cost of the particular monument or cost of the particular asset. I mean, and then if it comes to something that has been used for some time, that means okay, depreciated value of it, okay, net present value, whatever. That is the cost that you bear, but that is nothing. The point is that if any infrastructure project asset, if it collapses, it has a wide-ranging impact on the economy, in the immediate economy. Suppose on a bridge, a major bridge, it collapses, then surrounding that, there may be a lot of industries, there may be a lot of other things, economic matters going around. So all of a sudden, there is a disruption, and that cost of that disruption can be manifold. I mean, so that's really a matter of worry. Now, it's apart from the fact that we have seen, okay, loss of life, this is one thing. I mean, there's a social disruption to that extent. But you cannot have this kind of infrastructure assets falling very quickly with a shorter life. The problem is that if we have actually seen this is happening too much, that means we either have not studied the subject properly before doing anything, or we don't know anything about it. If I go to the American manuals for bridges or something, there are 1,000 pages manuals which are available there. So very, very detailed. And the point is that these are followed. Now, all these manuals have been developed because they appreciate that the losses can be very huge if that anything happens. Today, either we also have it, but may not be as detailed, but the same manuals can be brought in at a general term, but we may not be very serious in implementing them. And secondly, the context. Every project has a different specification, different context. It's not that the whole big manual can be used to have a bridge here, bridge there, somewhere else. Every specificities have to be identified and taken care of right at that moment of time. Otherwise, the cost can go on and on. Not only even if the bridge doesn't fall, maintenance cost, if somebody takes care of it, can go on for a long period of time. Supposing something is in PPP mode and the maintenance expenditure falls on the head of the private sector. The private sector party actually ends up spending huge amounts of money on it, and his economics may just collapse. Yeah. Anything else?
Right, sir. Right, sir. Yes. Sanjay, sir, I want to ask you, how do you think the steel industry can collaborate with construction firms to ensure that the material used meet the necessary standard for safety and durability, sir?
Yeah, in fact, apart from steel industry also produces steel slag, and which is a very, very important ingredient for high quality roads. And in fact, today I was holding a discussion with the Central Road Research Institute scientists. So according to them, the life of a road constructed with steel slag goes up by 2.5 times. Cost comes down by more than half. Because the steel slag, when it is used for roads, it is used in smaller quantities. That's number one, apart from its durability and so on. So in fact, Government of India is also now pushing that such kind of ingredients, such kind of material should be used in a very, very inclement kind of weather conditions. Areas where they are like, it's been used in Arunachal and so on. That's number one. And secondly, about steel, what I'll say, steel industry is producing all kinds of steel. But again, whether we have the capacity to use to create steel structures, steel intensive structures, and that is a very, very big challenge. And right now, what is the steel intensity in our infrastructure and construction project? It needs to go up, I'll say in a linear manner. Then it can make a difference, and especially looking at the manner in which the climate change is happening. And we have seen this year, I mean, whether in fact, if you look at the numbers in terms of that, already since the pre-industrial era, our temperature of the planet has gone up by 1.4 degrees, and the threshold was 1.5 degrees. So that's the reason why we are looking at the temperature of 52 degrees centigrade and incessant rains and which and so on. So I'll say there is need for steel structures. In fact, making steel intensive structures and use higher level of steel so that it can withstand these kind of inclement weather, these kind of the calamities which happen. And as far as the steel industry is concerned, I know that we are one of the premier steel industry, steel producers in the world, produce all kinds of steel, especially not only to meet our own requirement, but also to cater to external markets.
I have one issue when it comes to steel quality. Now, nearly 80% of the steel that goes, structural steel that goes for construction, are produced by small and medium sector industries. And one doesn't know, there are questions about the quality of their products, although most of them claim that they're as good as those produced in an integrated steel plant. But we have steel from re-rollers, coming from shipbreakers, or scrap, re-rollable scrap. We have steel coming from induction furnaces, etc. Now, with 80% of our construction steel coming from these sources, and we are growing at a rapid pace, our steel consumption goes at about 8 to 9%, and our major producers cannot actually supply the right kind of steel, and they're confined to mainly large projects or government projects, then we have a problem definitely to face in the days to come.
Right, sir. So we have received many more comments, and there is one comment we have from Mr. Mohit for Mr. Sanjay Singh. He is asking, could you share the specification and codal standards prescribed for the steel slag to adhere for use in road construction or backfill? Does it require any treatment or valuation, etc.? Valorization.
Yeah, definitely valorization.
Yes, sorry about that.
So valorization is needed, and each steel slag from each different kind of furnaces and different kind of, I'll say, basically steel slag is a factor of the kind of iron ore which is being used and other ingredients which are being used in the steel making. So every steel slag is different, and it requires processing. So processing procedure is also fairly different for each kind of steel slags, and there is nothing standard about it. So that needs to be kept in mind, and And steel slag cannot be used just out of the furnace. I mean, as soon as it comes out, it cannot be used for road construction. Initially, in the initial part, when this kind of thinking was quite pervasive, that steel slag can construct good roads, and the roads were constructed and developed cracks. So unless heavy material, heavy metals are extracted from steel slag, it cannot be used in road construction. Otherwise, leaching happens and so on. So processes. There are processes, and there are there is some kind of standard. In fact, I'll say this kind of process is not yet concretized, and it's in the development phase, and not much of steel slag road has been constructed. And although we produce a lot of slag, in fact, 20% of the steel, the slag is in the proportion of 20% of steel we are producing. So there is a lot of need for that, and that will also reduce the kind of the hit on the I'll say our natural I'll say these mitti, gitti, and all those kind of things which are required for road.
And I want to suggest, Mohit ji, regarding the steel slag specification, if you want to know, there are two ways. One is you can reach out to Mr. Satish Pandey, who works with CSIR, CSRR, isn't it?
RRI.
Yeah. Yes.
RRI.
And his presentation, he made a presentation in our conference in the month of March. That is also available with us on our YouTube channel. So you can visit to Metalogic PMS on YouTube and find Mr. Satish Pandey's presentation. So the recording is uploaded there. I want to take one or two more questions. One we have from Mr. Chaitanya PT. He's asking how well is recycled steel being accepted in the construction of these infrastructure project? Anyone can comment on this?
The large projects of the government are using mostly steel from the main steel producers, large chunk of it. It's a housing sector which is using most of the recycle or whatever other kinds of secondary sector steel. If all critical areas, either these are imported steel or still going from the major steel producers.
Right. And Mr. Suresh Khatoi is saying the reinforcement bar produced from secondary steel route is having 0.08% phosphorus due to availability of low-grade iron ore and being used in RCC structures. Should it be allowed when the IS specification is P 0.045% max? Will it not lead to failure in long run or at the time of earthquake? Abhay sir, yes. Over to you.
There was earlier a concept of primary and secondary steel. Okay, when the re-rolling is steel, but now that term of secondary steel has been removed. Now there is no primary or secondary. All steel should conform to IS 1786. And even the people who are, even the industries, steel industries, manufacturers who are making the recycled steel, they are producing the steel conforming to specifications laid down in IS 1786. See, any steel which is not conforming to the specifications laid down in 1786 is not okay for the use in the construction from any manufacturer. But if it is conforming to all the physical and chemical tests, then it is allowed. So this is the differentiation nowadays. There is no definition of secondary steel nowadays.
But in the layers and layers of subcontractors which come into play, at various stages, the steel, the specifications may change, and what is on paper and what actually being used just can get lost.
See, that is the another aspect. That is what I was saying. Now, if I mention on the my drawing M35 grade of concrete, if it is not achieved for some reasons, whatever, then designer is not responsible. So specifications are there. Their compliance has to be done. That's more important. We need to use a proper material. So there are standards, but no code restricts the steel to be used from the any manufacturer.
This is a
Suri sir,
quality,
yeah,
For a
Mr.
small,
Gawar.
quality,
Yes.
quality
Yes, sir.
assurance
Suri sir
protocol.
would correct.
Yeah, that has.
So these are going to be the final words because now the time is up. Yes, Suri sir and Mr. Gawar. Yes.
yeah, what I was trying to say is that recently we have found that many of the, advertisers we see on TV, our Saria is the best, our Rebar is the best.
Yes.
They have supplied IIS 1786 to NHA, and more than 10 of them have been blacklisted. So this is another issue, because NHAI has the testing methodology, so they have been able to catch them. But then builder will not be able to.
It's 100% misleading advertisement case.
Forgetting about the advertisement, when they supply along with the test certificate, and if the material is not conforming to the numbers given in the test certificate, okay, they are blacklisted by NHAI. But I think they should be given very wide publicity so that nobody buys from them. So, I mean, that's what I said. We don't have any legal framework to punish such people.
So I think
bad
about
quality-
18 to 20 companies have been blacklisted by NHAI recently.
Just imagine. Just imagine.
Yeah. Yeah,
So-
Mr. Gawar, you want to make a
Yeah.
point?
This is actually the quality. If we want to have, if you want to avoid failure, and if you want to have good quality, then the owning agency is also one of the big stakeholder. They should also take care, irrespective of the fact that whether it is NHAI or it can be a builder also. Builder also, that quality assurance protocol, if they are following, they are giving better quality. Even the owning agency should also take care of this aspect.
So with this, I like to close the webinar. I want to thank each and every one of you who have presented this. And as we come to the close of a 53rd webinar, I want to extend my heartfelt thank to each and every one of you for your participation and engagement throughout today's session on identifying the probable root cause of structural collapses. First and foremost, I would like to express my deep gratitude for our distinguished panelists, starting from Mr. Sanjay Singh, Mr. Yatendra Pal Suri, Dr. Abhay Gupta, Mr. S.S. Gawar, Dr. A.S. Firoz. Your expertise and insights have been invaluable. The discussion today have shed light on the complexities and critical aspects of structural integrity, and I'm certain that everyone here has gained a wealth of knowledge from your perspective. Thank you for sharing your experience and for contribution to a richer understanding of the issues at hand. At hand, your dedication to advancing safety and excellence in our industry is truly commendable. To our audience, I cannot thank you enough for your active participation. Your questions, comments, and engagement have added immense value to this webinar. It is your curiosity and drive for knowledge that make these sessions so impactful. And let me tell you, the recording of the program will be available on our channel on YouTube. Please type Metalogic PMS on your YouTube app and subscribe to the channel. I hope that you have found the discussion informative and that they have sparked the new ideas and consideration for your work. I would also like to acknowledge and thank the entire Metalogic team for their hard work in organizing this webinar. Behind the scene, a great deal of effort goes into ensuring everything runs smoothly, and today's session is a testament to their dedication. As we conclude, I encourage all of you to continue the conversation that started here today. The challenges we have discussed are ongoing, and the solutions will require ongoing collaboration and innovation. Let's stay connected and continue to share ideas as we work toward safer, stronger, and more resilient infrastructure. Once again, thank you all for being a part of this important discussion. I look forward to seeing you at our future events. Until then, stay safe, stay inspired, and let's keep pushing the boundaries of what's possible in our industry. Have a great day ahead. Have a great evening, everyone.
Thank you, everybody. Thank you, Monica.
Thank you. Thank you.
Thank you so much, sir.